and Assalamualaikum. My name is Muhammad Arif Irfan bin Muhammad Zamri from class DKA3B. My metric number is 11DKA19F1007. Today I will do a presentation from my case study about effective stress and lateral earth pressure. First of all, we should know what is effective stress and lateral earth pressure. Effective stress can be defined as the stress that keeps particles together. In soil, it is the combined effect of pore water pressure and total stress that keep it together. Concept of effective stress is fraction of the normal stress at a given depth in a soil mass is carried by water in the void space and fraction carried by the soil skeleton at the point of contact of the soil particle. Lateral earth pressure is the pressure that soil exerts in the horizontal plane. The common application for lateral earth pressure such as tunnel, basement, and a retaining wall. The application that I chose for my case study is retaining walls. Retaining walls have four main types such as gravity walls, piling walls, cantilever walls, and mechanical stabilization earth wall. Retaining wall is a vertical structure that holds back soil to prevent erosion and create level areas in a landscape. In specific, I chose cantilever retaining walls. Cantilever retaining walls are constructed of reinforced concrete. They consist of a relatively thin stem and a base slab. The base is also divided into two parts, the heel and toe. The heel is the part of the base under the backfill and the toe is the other part of the base. This is the picture of cantilever wall at construction MRT Laluan 2 Station Equine Park. How cantilever wall works? This wall cantilever loads to a large structural footing and convert horizontal pressure from behind the wall to vertical pressure on the ground below. This wall resists toppling over by allowing the weight of the soil to hold down the reinforced base of the wall. Now, I show you terminology component of retaining walls. Next is mode of failure. There are three failures which are: first, overturning failure. Overturning failure is rotation of wall about its toe due to exceeding of moment overturning to moment resisting. Second, sliding failure. Sliding failure is sliding of wall away from backfill when there is shearing failure at the base of wall. Last one is bearing failure. Bearing failure is pressure exerted by resultant vertical force at toe wall must not exceed the allowable bearing capacity of soil. Now, I will continue with lateral earth pressure to cantilever retaining wall. Lateral earth pressure is important parameter for design of retaining wall. Lateral earth pressure is the direct result of horizontal stress in the soil. The pressure on soil can categorize into three conditions which are at rest state, at active state, and at passive state. Lateral earth pressure acting can exist and develop in three different categories. First, at rest state. If wall is absolute rigid, earth pressure at rest will develop. Second, at active state. If wall deflect away from backfill, an active pressure will develop. Last, at passive state. To counter active pressure on wall, passive pressure will develop towards to backfill. How to prevent wall failure? For bearing failure, check foundation, such as increased size foundation or deep foundation. For overturning failure, try to increase size heel, toe, and stem. And for sliding failure, try to increase length of heel and apply shear key. This is an example of a failure of cantilever retaining wall, which is happened in Malaysia in 2014. This is incident that happened because of heavy rainfall and improper drainage system. In conclusion, retaining wall is a structure that used to maintain different level of height. Lateral pressure is important parameter for design of retaining wall. JKR slope guideline is reference for engineer to design of wall to ensure wall is safe. That's all from me and thanks for watching. Assalamualaikum.